So for the final part of this example, we will talk about kind of evaluating the pros and cons of what we've just done. So now that you've seen how it works, we'll talk about whether this was worth it in terms of the effort required to add yet another degree of parallelism. So what are the good things? Well, the good things of doing this is, as we'll see, we can improve program performance relatively transparently to some parts of the program. And in particular, you can see that this ParallelSpliterator version performed very well. It's the best performing of all the different ways of doing this stuff, at least on my laptop. I'm excited because I'm getting a new laptop here shortly, which will have 6 hyper-threaded cores, so it'll be fun to see if it runs even faster. I think it also has 64 gig of memory, so I'll be curious whether that makes a difference in which one runs faster. I'm sure it'll run faster, just because the processors are faster and the cache is more and we'll have more cores and so on. But I'll be curious whether it changes the relative ordering of any of these kinds of things. You'll also notice that when I ran this on my MacBook Pro, which is actually the computer I'm using right now, that one, the ParallelSpliterator version, ran the fastest, but not a heck of a lot faster than the Parallel Streams version. You can see it was probably in the variance range as to which one was faster. So this one on my Windows box, noticeably faster. On the Mac, not a whole lot faster. Why do we get a speed up? When we get a speed up, the reason we get a speed up is because there is finer grained parallelism, which means that we're having more things that can run in parallel, and therefore the cores that we've got will be kept busier. And that's the name of the game, is keeping the cores busy. So if you keep the cores busy, life is good. The changes we had to do here were relatively minor at one level. All we did was change the use of this Boolean from false before to true, so that was good. That part was good. This part of the program didn't really change other than changing the flag. However, to be perfectly honest, writing the parallel version of the phrase match spliterator was not easy, and we'll talk more about that in a second. As you may have guessed when we looked through the code, there were lots of subtle edge cases to have to deal with. So that leads us to the cons. So the cons of this particular example was that writing the parallel portion of the phrase match spliterator was a tricky, tedious thing to do. By the way, this is not always the case, right? So if you have much simpler collections you're trying to splitterate, like an array list, then it's not hard at all, as you'll see when you do your, or you've probably already seen if you do assignment 2B with the splitterator. Not too hard at all to splitterate an array. But splitterating something where you're searching, where you don't want to go across the boundaries of chunks when you search for phrases, that's a lot harder to do. So we have to split things very, very carefully. And for that reason, it's very good to get in the habit of unit testing your code. When I first did this, I had some bugs in my code. And later I came back and said, boy, that was weird. I don't know why it's getting me these strange results. So then I wrote some unit tests that were much more thorough in testing to make sure things worked. I should have done that the first time, of course, but I got strapped for time. Ironically, writing the ParallelSpliterator took longer than writing the rest of the program. The rest of the program was pretty straightforward to do. The ParallelSpliterator took a long time because it was just so subtle, trying to keep all the edge cases intact and making sure it preserved the correctness. Okay, so that's just a quick summary of the pros and cons of parallel splitterators that are very advanced, like this one is. Again, most parallel splitterators are not this complicated.